All right, for this unit, we want to start out by rewriting the cube root of x to the fifth in rational exponent form. So if I look at my formula here, that's going to tell me that my base is inside, so I know my base is x. All right, my exponent would be here, so my exponent would be 5 over my root, which is outside, which would be 3. So the exponential form of the cube root of x to the fifth is x to the 5 over 3. You do this one, rewrite the fifth root of x to the seventh in rational exponent form. On this one, we want to rewrite x to the 2/7 power in radical form. So radical means that it's going to have a radical. I know that x is my base, and my base goes inside the radical. I know that my root is 7, it's the denominator, and the root goes outside. And I know that my exponent is my numerator, and my numerator goes inside. So the radical form of x to the 2/7 would be the 7th root of x squared. You do this one, rewrite x to the 3/7 power in radical form. All right, in this unit we're talking about rational numbers, and we're talking about irrational numbers, or numbers that are not rational. Rational numbers are numbers that can be written as a fraction. All right, so notice your fractions are here. There are also decimals that end, or decimals that repeat, or square roots or cube roots or radicals that can be simplified into a fraction without a radical. So all of those are rational numbers. If they're not rational, they're called irrational. All right, so over here are examples of irrational numbers. If you put the square root of 8 in your calculator and found the decimal equivalent, it's going to be a decimal that randomly goes on and on and on forever. It never stops or doesn't have a pattern of repeat. And so the same way with this example, 1.6, the square root of 2/5, pi is probably your most perfect example of an irrational number. But what I always do is I put them in my calculator and see if they terminate or end or, go on forever without any specific pattern. So what I want you to do is I want you to state which of the following, are they rational or irrational? State if it's rational or irrational. Rational or irrational? Rational or irrational? Make sure you put that one in the calculator to see. On this one, which expression is equivalent to the square root of m divided by m to the fifth? Now, I think in order to do that, simplify that, we need to get it all in one form. So I'm going to rewrite the square root of m to be m to the 1/2 power over m to the 5th power. And then if we use our rules of exponents, I know since it's a division property, we're going to subtract the exponents. So that would be m to the 1/2 power, subtract 5. And if we put that in our calculator, 1/2 subtract 5, it's going to give us our answer of m to the negative 9 over 2 powers. And if you notice, there is not an answer that has negative 9/2. B has positive 9/2, but that wouldn't be it because it's not negative. All right, remember your rule about a negative exponent, it has to be moved to the denominator. So that would be the same thing as 1 over m to the positive 9/2. And if you rewrote that in radical form, that would be the square root of m to the 9th power. So A is your answer. On this one, they want you to do the same thing. So you need to rewrite that in exponential form. So if I wrote that in exponential form, that would give me f to the 5 over 2 power. over f squared. Now I want you to use your exponent rules to simplify. So if I simplify that, that tells me if it's a division problem, I'm going to subtract. So that would be f to the 5/2 powers subtract 2. What's your answer? So if I work that out, 5/2 minus 2 is f to the 1/2 power. You can write that in radical form and get your answer. Number 9, which expression is equivalent to the cube root of 27 x to the 2/5? Now, if you use your properties, you know that you can split this up. So that would be 27 x to the 2/5 power. And I can rewrite that in exponential form, which would be the 1/3 power. I know if I have a product that I'm raising to a power, then I can distribute my exponents. So that'd be 27 to the 1/3 power times x to the 2/5 power times 1/3. And then I would work that out. 27 to the 1/3 power is 3, if you put that in your calculator, times x, and I need to multiply my exponents here. So 2/5 times 1/3 is 2/15. So my answer would be B. I want you to work this one out. First of all, write it in exponential form. So that would give me 125 x to the 5th power, y to the 20th power, and z to the negative 4th power, all raised to the 1/3 power because I changed cube root to 1/3. Now, you want to make sure that you distribute your exponent. So that would give me 125 to the 1/3 power times x to the 5 times 1/3 times y to the 20th times 1/3 times z to the negative 4th times 1/3. So simplify that. (25 to the 1/3 is 5. If I multiply my exponents for x, that's going to give me 5/3. If I multiply my exponents for y, that's going to give me 20/3. And if I multiply my exponents for z, that's going to give me negative 4/3. And then make sure you write your answer without a negative exponent. Which expression is equivalent to the square root of x over x cubed? So again, you want to write that without radicals in the same form. So I'll rewrite the square root of x to be x to the 1/2 power over x to the 3rd power. So that tells me to simplify it. I've got the same basis, so I'm going to subtract my exponents. So x to the 1/2 subtract 3, which is going to give me x to the 5/2, negative 5/2. And again, you know you don't want negative exponents, so that would be 1 over x to the positive 5/2. And if you write that in radical form, the answer would be C. If you do this one, I would change it all to exponential form first. So that would be c to the 1/3 times c to the 1/4 over c to the 1/5. Now you want to use your exponent rules. So since it says multiply here, I'm going to add my exponents. That will give me c to the 1/3 plus 1/4 over c to the 1/5 which is going to be c to the 7/12 over c to the 1/5. So that's going to give me c to the 7/12, subtract 1/5 because it's division, and you're going to get your answer. On this problem, which expression is equivalent to, the easiest way to do that is put that simply in your calculator. So if you press the square root button and make sure you hit your fraction button. If you put that in your calculator, it's going to give you the answer. Which would be D. Same with this one, put it in your calculator to get your answer. And see what your answer is. Which expression is equivalent to the cube root of 64x to the 6/7? All right, so you want to make sure that you go ahead and write that in exponential form. So that would be 64 x to the 6/7 to the 1/3 power. So distribute your 1/3, so 64 to the 1/3 power times x to the 6/7 times 1/3. So if I put 64 to the 1/3 power in my calculator, that tells me it's 4 times, I need to multiply my exponents. So I have 6/7 times 1/3, that would give me 2/7. So my answer would be A. You work this one. Write it in exponential form first. 27x to the 2/5 raised to the 1/3 power. Distribute your exponents. 27 to the 1/3 power times x to the 2/5. And I need to multiply those exponents. And simplify to get my answer. Let A be a non-zero rational number. Let B be an irrational number. So usually what I do is if I let 1 be my rational number, and I let B be my irrational number, my favorite irrational number is pi. Which of these must be a rational number? So if I do A, pi plus 0 equals pi. So is that rational or irrational? Pi is irrational, so I'm not looking for that one. B, A plus A. So I let A be 1. 1 plus 1 equals 2. Is that a rational number? Yes. So there we go. There's my answer. You do this one. A number can be written in the form of A over B, where A and B are integers and B does not equal 0. Which is known as the following? What do you call a fraction? Number 14. Which statement is true about the value of the square root of 8 plus 4 times 4? Well, I would distribute that. 4 times the square root of 8 is 4 square roots of 8. Plus 4 times 4 is 16. If I put that in my calculator, I get the answer. And it's a decimal that's repeating. So I know that my answer is irrational. So I know that my answer's got to be not A or not B. So it says it's irrational because the product of two irrational numbers is irrational. So I would say square root of 8 plus 4 is an irrational number, but 4 is a rational number. So that would eliminate choice C. D says it is irrational because the product of an irrational number and a rational number is irrational. So I'm multiplying irrational times irrational. So there's my answer. You work this one. Which expression has a value that is a rational number? Well, the only way you can do that is work it out. What is the square root of 10 plus 16? So in decimals, that gives me 19.1622776, so on. So that's irrational. If I do the second one, 2 parentheses, square root of 5 plus the square root of 7 equals, hit the SD button, 9.7636385777, and so on. So that's irrational. C, the square root of 9 plus 4 equals, put that in your calculator, 5. There's my rational number. It's a whole number. Which expression has the value that is a rational number? You need to do the same thing. Review questions. In the triangle below, GH is parallel to DF. What is the length of GE? Well, GE is right here, so let's put X. Again, if you remember nothing else from geometry, remember that you use proportions. So I'm going to use the numbers on my left side as my first fraction, X over 3, equals the values on my right side, 6 over 4. When I cross multiply, I get my answer. So what's the value of GE? In the coordinate plane, segment PQ is a result of a dilation of XY by a scale factor of 1/2. Which point is the center of dilation? So to do that, you want to match up your corresponding points. So I'm going to draw a line from X, the bottom point in the first image, to the bottom point in the second image. And I'll make my line long, and there's my line. I want to do the same thing with Y and its corresponding point, Y and X. And there is where they intersect. To find your center of dilation, you locate the point where they meet, which would be right there. That is my X coordinate of -4 and a Y coordinate of 0. So there's the center of dilation. Consider the triangles which can be used to prove the triangles are congruent. You want to label your marks. So I know that this mark here tells me that angle A is congruent to angle D. Those are angle marks. I notice that 2 marks here tells me angle B is congruent to angle E. That's an angle mark. And I notice that there's a mark here that tells me AC is congruent to side EF, DF. So those are side marks. So I know I have 2 angles in a side, so A and C would be out. And I have to decide, is the side between my 2 angles or not? And you choose the answer. Next one, what is the area of the shaded part of the circle? Well, I can tell from the picture that 75 degrees of the circle is not shaded. So to find the degrees of the shaded part, I would say 360 minus 75, which would be 285 degrees. So if I use my chart, I know to find the area of the sector, I've got to compare the degrees of the shaded part, which is 285, to the degrees of the whole circle, which is 360. To find the area of the shaded part, I'm going to say X, and I need to find the area of the circle. So that's pi times radius squared, which in this case is 9. And you want to cross multiply to solve that. You get the answer. The last one, what is the volume of a cylinder with a radius of 3 inches and a height of 9/2? To me, it helps to draw the picture. I have a radius of 3 inches and a height of 9/2. If I go to the formula sheet and find the formula, V equals capital B times H, where B represents the area of the base. So I can tell my base is a circle. So the area of the base is going to equal pi times r squared. So that's going to give me pi times 3 squared. If I put that in my calculator, I get pi. So I'm gonna substitute that over here for my area of my base. And I look at my picture to find my height. That would be 9/2. And I multiply to get the volume of the cylinder. So that's it for this unit.